indeed the true winds on Earth, the surface winds, are much more complex than shown in these simplified diagrams. And there are two reasons for it. One is we have a continents, unevenly distributed continents, and the other reason is we have a tilted Earth axis, which creates the seasons. So you get seasonal changes of the exposure to the sun, or the daytime hours, the daylight hours, and that results in changes in the air density and creates different types of seasonal variations in the wind distribution. They are shown here. The top distribution shows you January wind distribution, and the bottom distribution shows you July distribution. And there are two features shown. The arrows indicate the wind direction. And you can see the intertropical convergence zone. It's this fat line that does not perfectly follow the equator because of the influences of land. You can see regions which are called H, and these are high pressure regions where the air pressure is high, and you get indications of L where you have a low pressure zones, and this high and low pressure corresponds to warm and cold zones, if it's situated over land. But you can still, if you look at it, you can still identify the trade winds, and you can still identify the westerlies. However, there are regions where you have the big seasonal differences. Have a look. What you should do is look at the top one and look at the bottom one. Look up and down and up and flip and flop. What do you see? Where are the differences? And if you look at it, you see the biggest differences are actually over the Indian Ocean. So here's the Indian Ocean. And you can see that the intertropical convergence zone varies tremendously. In January, which is the northern hemisphere winter, it just almost follows the equator. So that's a typical situation. You have tropical convection driving it. This is pretty much the intertropical convergence zone follows pretty much the equator. However, during northern hemisphere summer, the Asian continent heats up and actually shifts the tropical convection. Is shifted over the continent. The intertropical convergence zone is moved northward, and the surface winds that feed in the tropical convection come from the Indian Ocean, and this is where the wind reversal takes place, and this is what we call the monsoon.